You've been told that wood stores energy. That when you light a match, you're releasing it, unlocking something that was waiting inside, like opening a pressurized container. Like cutting a rope that held a weight suspended. That's the wrong picture. Energy isn't stored in wood the way water is stored in a tank. There's no reservoir, no hidden chamber, no potential waiting to burst out. What you call stored energy is just a measure of instability. Wood is made of molecules: carbon, hydrogen, oxygen, locked into arrangements that are not the most stable way those atoms could exist together. The bonds holding them are strong, yes, but they're not the strongest bonds those atoms could form. So the energy isn't trapped, it's elevated. Think of it this way: a ball sitting on a hill doesn't store the energy of falling. The ball is simply higher than it could be. The energy you talk about is just the difference between where it is and where it could go. Wood is the same. Its molecules are sitting on a metaphorical hill. They're not holding energy, they're just not at the bottom yet. When wood burns, atoms don't release energy. They fall. And when they land, when carbon bonds with oxygen from the air, when hydrogen does the same, they form molecules that are more stable, lower, tighter, happier. If atoms had preferences, the energy you see is heat and light. That's not coming from the wood. That's the difference between the hill and the valley. That's what it feels like when molecules fall into place. Feynman said it clearly: the energy released in burning is just the energy difference between the initial and final molecular arrangements, not a release, a descent. And once you see it this way, you realize fire doesn't destroy anything. It just lets things become what they wanted to be all along. Look at a piece of wood. It seems stable, solid, permanent. It's been a tree, a branch, a plank. It's sat in a forest for decades, maybe centuries, doing nothing. But that's not stability. That's a standoff. Wood is made of cellulose, lignin, chains of carbon and hydrogen twisted and stacked into fibers. These molecules are big, complex, and they are absolutely not the most stable thing those atoms could form. If carbon had a choice, if atoms operated on preference, they wouldn't stay locked in wood. They'd rather be carbon dioxide. Hydrogen would rather be water. Those molecules CO and HE or lower energy configurations. The bonds in those molecules are stronger, tighter, more thermodynamically favorable than the bonds holding wood together. So why doesn't wood just fall apart on its own? Why does it sit there, year after year, not turning into ash and vapor? Because there's a barrier, not a physical one, an energetic one. To break the bonds in wood, the carbon-carbon, carbon-hydrogen, oxygen-hydrogen connections, you need energy input. You need to snap things apart before they can rearrange. The molecules are like a boulder wedged at the top of a hill. It wants to roll down, but it's stuck. It's not stable because it's happy. It's stable because it's trapped. And that's what makes wood so strange. It's a high-energy structure pretending to be permanent. It's a system waiting to collapse, held in place only by the fact that collapsing requires a push. Feynman called this metastability, a state that looks stable but isn't. A state where everything is ready to fall, but nothing has nudged it yet. Wood doesn't want to be wood. It wants to be smoke. You've been told oxygen feeds fire, that it's the fuel, the enabler, the thing that makes combustion possible. That's backwards. Oxygen doesn't feed anything. It's not consumed in the sense you imagine. It's not eaten or destroyed or sacrificed. It's preferred. Here's what's actually happening. The carbon atoms in wood are bonded to other carbon atoms, to hydrogen, to oxygen already inside the wood structure. These bonds are okay. They work. But they're not optimal. Now introduce oxygen from the aero molecules floating around, unattached, available. Carbon looks at that oxygen and finds something interesting. Bonding with oxygen is more stable than staying bonded to the wood structure. The bond between carbon and oxygen, the bond that makes CO, is stronger, lower in energy, more thermodynamically favorable than the bonds carbon currently has. Same with hydrogen. It's loosely connected in the wood, but pair it with oxygen, you get how water, one of the most stable molecules in existence. Oxygen isn't fuel. It's a better partner. It's the attractive option. The more stable arrangement, the molecular equivalent of a lower valley. And when carbon and hydrogen encounter oxygen, they don't combust. They switch. They leave their old bonds and form new ones. This is what burning is. Not destruction, not consumption. Just atoms changing partners, moving from unstable arrangements to stable ones. The wood falls apart not because oxygen attacks it, but because oxygen offers a better deal. And the atoms take it. Feynman put it simply, oxygen doesn't make fire. It makes carbon and hydrogen prefer to be something else. That preference, that chemical attraction, is the only reason fire happens at all. Without oxygen, carbon and hydrogen stay stuck. With it, they fall. You think the flame is the fire, that the glowing, flickering light you see, that's where the burning happens. It's not. The flame is a side effect, a symptom. The actual reaction, the place where carbon grabs oxygen, where hydrogen forms water, where molecules rearrange, happens at the surface of the wood, in the solid, in the boundary between matter and air. The flame is just what happens after. Here's the sequence. Wood heats up, its molecules begin to break apart, not burning yet, just fragmenting. This releases gases, volatile compounds, small hydrocarbons, carbon chains that evaporate into the air above the wood. Those gases rise. They're hot, they're still reactive, and as they drift upward, they encounter oxygen in the air. They rearrange. They fall into more stable forms, and when they do, when the bonds snap and reform, the atoms don't land softly, they land violently. The excess energy from that molecular descent doesn't just vanish. It gets dumped into the surrounding space as kinetic energy, heat, and some of it excites electrons inside the newly formed molecules, kicking them into higher energy states. When those electrons fall back down, they release light. That's the flame, not the reaction itself, just the light from molecules that have already reacted, the glow of atoms shedding their excitement. The flame is a cloud of hot, transitioning molecules radiating their excess energy as photons. It's not fire, it's the exhaust of fire. You've been watching the wrong thing your entire life. The real burning happens silently, invisibly, at the surface of the wood. The part you don't see. The flame is just the universe cleaning up afterward. Feynman knew this. He'd point at a candle and say, the flame is not where the wax burns. It's where the vapor of the wax finishes burning. The fire you see is the ghost of a reaction that already happened. You've always thought heat causes fire, that you add heat and burning begins. That heat is the trigger, the spark, the reason. It's not. Heat doesn't cause anything. It just removes the obstacle. Remember, wood wants to rearrange. Carbon wants to bond with oxygen. Hydrogen wants to form water. The molecules are already unstable. The fall is already waiting to happen. But to rearrange, the old bonds have to break first. And breaking bonds costs energy. Not much, not permanently, but enough to create a barrier, a threshold, an activation energy. Think of it like this. You have a boulder sitting in a shallow dip at the top of a hill. The valley below is much lower. The boulder wants to roll down, but the dip holds it in place. You don't need to push the boulder down the hill. You just need to nudge it out of the dip. Once it's free, gravity does the rest. Heat is that nudge. When you apply heat to wood, you're not adding energy that makes it burn. You're adding just enough energy to break a few bonds, to crack the molecular structure, to free a few carbon and hydrogen atoms so they can find oxygen. And once they do, once a few molecules rearrange, they release energy, heat, which breaks more bonds nearby, which frees more atoms, which release more heat. It cascades. The reaction becomes self-sustaining, not because heat is fuel, but because the first fall triggers the next, and the next, and the next. Heat is the gatekeeper, not the cause. You don't need to keep adding it. You just need to remove the barrier once. After that, the molecules fall on their own. Feynman described it exactly this way. Activation energy is not the energy of the reaction. It's the energy needed to let the reaction start. The hill was always there. The valley was always lower. Heat didn't create the descent. It just opened the gate. And once the gate is open, everything falls. Stop calling it burning. That word carries too much baggage, too much violence, too much destruction. Nothing burns, things just fall. Here's the abstraction. Every chemical reaction is a rearrangement from a higher energy state to a lower energy state. Molecules sitting in unstable configurations, shifting into stable ones. Combustion is not special. It's just steep. When wood meets oxygen, the energy difference between the initial state and the final state is large. The fall is dramatic. That's why you get heat. That's why you get light. That's why it feels like something violent is happening. But zoom out. Look at iron rusting. Carbon and hydrogen in the iron's surface rearranging in the presence of oxygen, forming iron oxide. Releasing a tiny bit of energy. It's the same process, just slower, shallower. The molecules are still falling. The energy difference is just smaller, so the descent happens over months, years. No flame, no heat you can feel, but molecularly identical. Rusting is combustion in slow motion. Your body does this too. You eat food. Molecules in high energy configurations. You breathe oxygen. And inside your cells, enzymes carefully break those food molecules apart and let carbon and hydrogen bond with oxygen. Glucose becomes CO and water. The exact same products as burning wood. You are a slow fire, controlled, regulated, but thermodynamically indistinguishable from a campfire. The only difference is speed and control. Feynman said it outright. There is no fundamental difference between the combustion of wood and the metabolism of sugar. Both are just molecules falling to a lower energy state. So when you ask why fire burns, you're asking the wrong question. Fire doesn't burn, molecules fall. And they've been falling since the universe began. Combustion, rust, respiration, digestion, decay, all of it. Every chemical process you've ever seen is just matter finding its way downhill, falling into configurations the universe prefers, and the universe, for reasons no one fully understands, prefers stability. You think burning is something that happens to objects. To wood, to paper, to fuel. Not to you. But right now, as you read this, your cells are doing exactly what fire does. They're taking high-energy molecules, glucose, fatty acids, amino acids, and rearranging them in the presence of oxygen. Carbon and hydrogen, bonded in complex chains, are being pulled apart, and they're forming the same products wood forms when it burns, carbon dioxide and water. The difference is control. Your body doesn't let the reaction cascade. It doesn't let all the glucose molecules fall at once. That would release too much heat too fast. You'd cook from the inside. Instead, enzymes guide the process. They lower the activation energy in careful steps. They extract the energy difference in controlled portions, storing some in ATP molecules, releasing some as body heat, but the thermodynamics are identical. You are combusting glucose. Slowly. Carefully. But combusting. And this reframes everything. Burning isn't a destructive event. It's just what happens when molecules rearrange. And molecular rearrangement is constant. It's everywhere. A cut apple turning brown, the same process. Oxygen bonding with molecules in the apple's flesh, pulling them into lower energy states. Banana ripening, molecular descent. Chlorophyll breaking down, sugars rearranging, cells shifting towards stability. An old photograph fading. The dye's complex, unstable molecules falling apart in the presence of oxygen and light, collapsing into simpler, more stable forms. None of this looks like fire, but it is. Feynman understood this deeply. He'd say, life is controlled combustion. Every breath you take is part of a slow burn. And once you see it, you can't unsee it. You're not separate from fire. You are fire, just slow enough to stay intact, just controlled enough to be alive. But burning, nonetheless. You now understand the mechanics. Molecules fall from high energy states to low energy states. Bonds break and reform. Atoms find more stable partners. Fire is just a steep, fast version of something happening everywhere, all the time. But here's where Feynman stops you. Here's where the explanation ends and the mystery begins. Why does the universe prefer lower energy? Why do molecules want to fall? You can describe it. You can measure it. You can calculate the energy difference between wood and carbon dioxide with extraordinary precision. But you cannot answer why that difference matters. Why does nature move towards stability? Why not the opposite? Why don't atoms spontaneously climb uphill, forming more complex, higher energy structures? You might say, because of entropy, because the universe moves toward disorder. But that just rephrases the question. Why does entropy increase? Why is that a law? Feynman was asked this once. A student wanted to know why fire burns at the deepest level, not the mechanism. The reason. And Feynman paused. Then he said something like this. I can tell you how it happens. I can describe the forces, the energy differences, the molecular rearrangements. But if you ask me why the universe is built so that things fall toward lower energy states, I can't tell you. No one can. That's just how it is. It's the bottom. The Place where explanation stops. Physics can describe the rules. It can predict what will happen. It can tell you that wood will burn, that glucose will metabolize, that iron will rust, but it cannot tell you why those rules exist. Why is less energy the direction everything flows? Why does the universe have a preference at all? You can call it thermodynamics. You can call it the second law. You can write equations that describe it perfectly, but you're still just describing the pattern, not explaining why the pattern is there. And this is what Feynman wanted you to feel, not certainty, not mastery. Because the deeper you go, the more you realize. We live in a universe that has direction. A universe where every atom, every molecule, every structure is gently or violently sliding towards some lower state, and no one knows why it slides at all. You don't understand fire. You understand what fire does, but the reason it does it, that's still wrapped in the same mystery as existence itself.